So to add to the tricks up our sleeves, as far as factoring is concerned, first we looked at perfect square trinomials, then we looked at difference of squares. Now we are still looking at a difference of squares, but it gets a little bit more difficult to recognize. In this instance, we're looking at a situation where we can kind of factor by grouping. We look at the first few terms, and we can factor that, and then we end up with a difference of squares. If you'll notice, x squared minus 10x plus 25, that's a perfect square trinomial. X is squared, 25 is 5 squared. So we're looking at that this is, and if we remember correctly, let's write this out again just for clarification. A squared minus 2ab plus b squared, that equals a minus b squared. And this is 2 times 1 times 5. It ends up being 10. So we do have a perfect square trinomial. So this is going to end up being x minus 5 squared minus y squared. And now we have a difference of squares again. And again, a squared minus b squared, that equals a minus b times a plus b. So in this case, though, we have a is a binomial. It's x minus 5. That's our a. So this ends up being a minus b times a plus b. So let's write that down as a minus b. So x minus 5. Our b is y, so minus y times x minus 5 plus y. And then if we just write that out without the parentheses, we end up with x minus 5 minus y times x minus 5 plus y. And you could write it as x minus y minus 5 times x plus y minus 5. Either way is perfectly fine. I'll go ahead and rewrite that with our constant last. So x minus y minus 5 times x plus y minus 5. And then if we wanted to check again, we could multiply through in order to verify that we end up with what we originally started with.